Welcome back. So we've already calculated a derivative once. Now we're going to try and do it again. We're still going to use that same slope equation, that fancy slope equation. That is our fancy y2 minus y1 all over x2 minus x1, which was our delta x. And then we want the limit as it goes to 0 so that we take that average rate of change, squeeze it to a single point. But now we're going to do it with a new equation. So let's write this out. Y prime, which is just another way of writing derivative, is going to be the limit as delta x goes to 0 of, let's find our f of x plus delta x. So that's just plugging this into our equation. So that would be the square root of x plus delta x. And our f of x is just going to be our normal equation. So now we can plug those in. So f of x plus delta x is square root of x plus delta x minus our f of x, which is square root of x, all over our change in x, x2 minus x1. Now I need to figure this out. You'll notice that if I plug in, let me reword that. Let me go back. The easiest way to solve this is to get rid of the roots on top. And the best way to do that is to multiply by the conjugate. And if I multiply by the conjugate on top, I have to multiply by the conjugate on bottom so it stays balanced. Now, here's what I want you to do. I want you to practice simplifying this algebraically. So what you're going to do is multiply out the top. Now, you're actually going to find in a second that it's better to leave the bottom as is. So pause the video, try multiplying out the top, and then simplifying as much as you can, and then press play, come back and see if you got it right. Okay, let's see how you did. So if you FOIL out the top, multiply out the top, you should get this, and your middle terms will cancel, and then I'm squaring my roots, so I don't have those anymore. So I have this came from that part squared, and then this came from that part squared. And then my x's cancel, so I'm just left with a delta x on top. And then here's why we didn't distribute the bottom out, because now my delta x's cancel, and I'm left with just that. Now we can actually do the limit by plugging in 0 for delta x. So I'm going to get 1 over square root of x plus 0 plus square root of x, which is 1 over square root of x plus square root of x. So that would be 1 over 2 square root of x. So y prime, that derivative, is that. That was a lot of work. In the next video, we're going to do one more example of finding the derivative using this definition.